This video is about what variation is, which is a surprisingly hard thing to define. One site said, in mathematics, variation recognizes how changing different parameters impacts variables. Variation is also defined by any change in some quantity due to change in another. And I want to recognize that these definitions might not make a lot of sense. One key part of understanding variation is first understanding what the heck a variable is and also what a constant is. So what is a variable? What is a constant? Do we always know exactly the value of that constant? Variables are so named because they are capable of changing. So variation is defined by any change in some quantity due to a change in another. So, for example, in the equation y equals ax squared plus bx plus c, the x and y are the variables. The x and the y are the things that are capable of changing. And what's more, a change in the x is sometimes called the independent variable, results in a change in the y. Constants, on the other hand, constants are a quantity that's unknown, that can be unknown, but assumed to have a fixed value in a specific mathematical context, according to dictionary.com. So examples of constants are all over in science, especially physics classes. Planck's constant, the speed of light. In chemistry, there's Avogadro's number. In math, there's pi. The a, b, and c in that same equation, y equals ax squared plus bx plus c, the a, b, and c, we might not know those values, especially initially, but they're assumed to be constant for that specific problem. This isn't to say that all of these equations have the same a, b, and c value, but it means for this specific problem, a, b, and c are constant, they're fixed. So putting that together with variation, we talk about how equations vary, and we describe this mathematically when we talk about the form an equation takes. So we talk about linear equation or linear variation. We talk about quadratic, exponential, inverse, and more. So for example, y equals 2x is a type of variation. We know this because as x, our independent variable, changes, it affects y, another variable. And I think I have too many commas on my slide. Another type of variation is y equals negative 1/3 x squared. Same reason, as x variable changes, it affects y, which is another variable. So this negative 1/3 and this positive 2 don't have to stay the same from problem to problem, but in a given problem, that negative 1/3 is always negative 1/3. So same type of variation with a different constant would be y equals 17x squared. So our constant may be different from this first problem to the second one, but it's still just a constant. It's going to stay 17 no matter what x is. Another example, y equals 1/x, is also a type of variation. Y equals 2 to the x power is also a type of variation. So many more. So let's look at these examples. What type of variation is taking place? For the first one, y equals 2x is linear variation. And we know that because it fits the form of y equals mx plus b. There's no squareds or dividing by x's. This is a linear change. Y equals 2x is a linear change. The second equation has an x squared. The squared means this is not linear. This is actually quadratic. Y equals 1/x is an inverse or reciprocal relationship. And this last one is what's called an exponential relationship. Here's the big question. How do we recognize which type of variation is happening? And this is one of the really big ideas in this class. By the end of this class, you should be able to walk away and recognize, oh, that's an inverse relationship. Recognize it from either the equation or the graph or a table of values. So I want you to be able to recognize linear, quadratic, inverse, and exponential. Thank you.